Okay, in this video we're doing our basic derivatives. We're going to start with polynomials and then work our way up to square roots and fractions. So we have these rules here, and by far the most useful one is this second rule where the power drops and you drop the power by 1, the number comes out the front. So for example, if I have something like x5, I'm going to have f dash of x equals x, 5x to the power of 4. So the 5 comes out the front and then the power drops by 1. That's how this stuff works. Okay, f of x equals x6 plus 1. The derivative here would be 6x to the 5. Now the plus 1 just completely drops off, and that comes from this rule here that constants differentiate down to 0. Also, if you've got a whole bunch of stuff added together, you just differentiate each bit. Now, if you've got something like this, then 3x4. So the 4 will come out the front, just like that, and it times us by the 3. So that leaves us with 12. X and the new power is still 3, you just drop it by 1. Now we got this next one here. If you ever run into a situation where it says y, I'll show you what to do. It's just different notation, dy dx for the derivative. And then same thing happens. So 4x cubed becomes 12x squared, because 3 times 4 is 12 out the front, and then the power drops by 1. Now, this term here, 2x. If you ever have something like that, where it's a number with x, then the x just goes away and you're left with that number. So let's do that. Take 2, and the plus 7 will just go away. Now here's where it gets a bit trickier. You need to use your index laws for fractions, and that's why I put the index laws in the topic booklet. We're going to be using this one here, which says that I can write a fraction as a negative power. In particular, if I've got 1 over x, that's another way of writing x to the minus 1. There we go. So a lot of people stop here because they think they've done the derivative. We have not done the derivative yet. We still need to do that. So what's going to happen? Well, the power is going to come out the front. So we're going to get minus 1x, and we drop the power by 1. What's 1 less than minus 1? Well, it's minus 2. So this becomes minus x to the minus 2. And if we think about what a power of minus 2 actually means, this becomes minus 1 over x squared. There we go. Next one we got here, so we need to rewrite this. So this is 2x to the minus 1 is our original function. And then if we start to look at the derivative, well, the minus 1 is going to come out the front and make it minus 2. And then we can rewrite that using index laws to that. All right, let's do this one. The original function is x to the minus 2. Now let's do the derivative. Minus 2x to the minus 3. Because the minus 2 has come out the front and we've dropped the power by 1. And I can rewrite this as minus 2 over x cubed. Alright, so how do we approach square roots? We'll just need to use another index law. So it's going to be this index law here. And in particular, root of x equals x to the half. So we rewrite the function as x to the power of a half. And then we need to differentiate it. So the half comes out the front, and we have minus a half. The reason for that is if we think about our number line, where here's 0, 1, and minus 1, we were sitting at a half. And if I take one step back, that puts me right here, which is at minus a half. So you'll be really careful with these fractions. Okay, let's think about what that means. 1 over 2. Now, x to the power of minus a half. So the minus will put it underneath the fraction, and the half will make it a square root. So that's root x on the bottom of this fraction. Now, how do we do a combined thing? Well, we just use our index laws. So 1 over root x becomes x to the minus a half. If I do the derivative, minus a half comes out the front. And our new power is minus 3 over 2. This may actually be easier for you to see if I use decimals, so I'll just do that. Our original one was minus 0.5, so minus 0.5 comes out the front. What's 1 less than minus 0.5? It's minus 1.5. So it depends which way you want to do it. Fractions are usually a little bit better, just in case you get something like a third, which you can't write easily as a decimal. but this will work for our purposes here. Okay, so this could become minus 0.5 over x to the 1.5. And if you want to get really fancy with fractions and simplifications, it all ends up being this. So minus 0.5 is minus a half. That's where that bit's come from. And if I want x to the 1.5, that's x to the 1 times x to the 0.5. We know x to the 1 is just x, and x to the 0.5 is root x. So that's where that bottom bit comes from. All right, next, find the slope of the tangent to that function at x equals 5. So first we need to just find the derivative, which is 3x squared. And if they're asking for the slope of the tangent, what they mean is what is the derivative at the value of 5, f dash of 5. So that's 3 times 5 squared, which is 3 times 25, which is 75.